Okay, in this assignment we are going to go through one Way Anova, two Ways Anova, and work with F statistics. So let's read the first question. In a test of weight loss program, 120 subjects were divided such that 30 subjects followed each of 4 diets. So 30 subjects were followed each of 4 diets. Each was weighted a year after starting the diet, and the results are in ANOVA table below. Use 0.25 significance level, 0.025, 2.5% level to test the claim that the mean weight loss is the same for the different diets. Okay, so to be able to draw conclusion about the claim, we are going to take our p-value, right? P-value is how much? P-value is 0.01, right? And our the alpha significance level is 0.025, which is 2.5%. So 1% versus 2.5%. What conclusion we can draw? So if p-value, you can take a note, if p-value is less than our alpha significance level, then we are going to, what does it say here? A level to test the claim that mean weight loss is the same for the different diet. Yes, so it's the same for different diet because our p-value from this table is less than the significance level. Okay, moving to question number 2. We have to check, of course. Question number 2. Samples of pages were randomly selected from 3 different novels. The flash reading E scores were obtained from each page, and from TI Plus calculate the results from analysis of variance given below, meaning here. Use 5% significance level. I'm going to write down alpha equals 0.05. All right. To test the claim that 3 books have the same mean. Okay, so our claim is since there are 3, it's going to be mu1 is equal mu2 is equal mu3, and this is our claim. Accordingly, null hypothesis is going to be, so at least one of them is not the same. At least one of means differ, put this way. So our question is, we need to test this claim that 3 books have the same reading score. All right, so how are we gonna test it? So we need to first we need to determine that mu1, mu2, mu3. We're gonna test that one, and then next determine what must be the true when the original claim is false. So what conclusion we can draw when original one is false? So I would say that at least one of the means differ. Let's see what we have. Oh, this is asking for the fail to reject. Okay, let's continue. All right, so what we're gonna do now, we're gonna get our alpha. We know our famous comparison, alpha versus p-value, right? So we have alpha 0.05. Now let's go get our p-value. 7.005 e minus 4, which means I have to go to the left by 4 signs. P 0.005. Let me write down. And then we have there some numbers. E negative 4. Am I right? 7.005. Sorry. Which means it's gonna be, so 7.005. So from 7 I'm going to the left by 4 units, which is gonna be 1, 2, 3, 4. This is gonna be our decimal notation. We'll move here 1, 2, 3 and till 7. So how many decimal notations we need? Oh, we need to draw conclusion. Okay, well, then we will do this way. We will get 4 decimals. So I will write down p is equal 0.007. So we're going to compare alpha to p-value. So what we can say, you can take a note of this, although you already know. So if p-value less or equal alpha, then we reject null hypothesis. Okay. If p-value greater than alpha, then we fail to reject null hypothesis. So we have what, p-value 0.007, alpha is 0.05, and we put less sign, right? And we get what? P-value is less than alpha. We reject null hypothesis. All right, so reject null hypothesis. Let me see. So it's going to be either B or C. So not B, I'm sorry, A or C. So let's see which one it's going to be the case. So in the case of C, we reject null hypothesis because there is sufficient evidence to warrant rejection. Okay, so if we have to reject, that means enough evidence to reject. A, what we have with A, reject, there is insufficient evidence to reject. So it's not gonna work. It's kind of nonsense. We reject with and that is the claim decision, but we don't have sufficient evidence to reject. So the answer is gonna be C. Okay. Moving to question number 3. Let's see what do we have here. So a sample of colored candles was obtained to determine the weight of different colors. The ANOVA table is shown below. Just to remind you, ANOVA table we use, it's a technique to use to test the means, the equality of means for several samples. Okay, here we have, and we have source, treatment, error. All right. So it is known that the population distributions are approximately normal, and that's a condition for populations. And the variances do not differ greatly, meaning we can approximately take them equal. So their difference is not significant. So use 0.025 significance level. Okay. Let me. Alpha is equal 0.025 significance level to test the claim that the mean weight of different color candies is the same. Okay, so our claim is going to be mu1 equal mu2, or in whatever we have mu3. This is our claim. All right. So if the candy maker wants the different color populations to have the same mean weight, do these results suggest that the company has a problem requiring corrective actions? Okay. So what we have to do, we need to take p-value and compare to alpha, right? Our p-value 0.7788. So what do we have? We have our p-value is greater than alpha, right? So what does that mean? We fail to reject null hypothesis, right? Here it is. Let me remind you. I could even move this down so we can watch it here also. There we go. So p-value is greater than alpha. We fail to reject null hypothesis. So if we are rejecting our claim, right, that means we are going to say that no. So we are going to choose no, right, since we are rejecting. So it's going to be either C or D. Which one? We chose rejection, failed to reject, because p-value was greater than significance level, right? Okay. So one more time the question. If the candy maker wants the different color population to have the same mean, do these results suggest that company has problem requiring corrective actions? Okay, null hypothesis is the claim. We fail to reject. That means we accept it. That means there is no problem requiring corrective actions. Therefore, we choose no. In between C and D, we choose D, because we fail to reject null hypothesis based on the fact that p-value is greater than alpha. So we definitely choosing D. Okay, let's check. We are good. So moving to next question. Oh, continue. So does the company have a problem requiring corrective actions? Well, we already said no, doesn't have any problem. But which one is it? Because it's likely that the candies do not have equal mean weight, right? Because we are rejecting, if we fail to reject our null hypothesis, that means we support, correct? And that means that it is not likely that they have different equal mean weight. So it's likely the candies do not, it's not likely the candies do not have equal, okay, this one. two negations make it positive, right? Not likely and not have, which means they do have equal mean weight. All right. Now we are moving to question number 4. So what do we have here? First of all, we need to choose hypothesis test. Let's read it. So the data found below, well, I can say that first one, it's already A answer cannot be the case because null hypothesis doesn't carry equal sign, right? So it's going to be B, C, or D. Let's figure out which one. C also cannot be, not equals inequality, null hypothesis. So it's going to be between B and D. Let's read the problem and figure it out. Equal, not equal, or at least one of means is different from others. So here is the problem. The data found below measure the amount of greenhouse gas emission from 3 types of vehicle, okay? The measurements are in tons per year, expressed as CO2 equivalent. Use 0.025 significance level to test the claim that, this is our claim, pay attention, that the different types of vehicle have the same mean. So it's definitely going to beat our claim. It's A, B, or D. Okay. Amount of same mean amount of greenhouse gas emission. Based on the result, does the type of vehicle affect the amount greenhouse gas emission? Okay, our case, it doesn't say equal or not equal, so it just say claim that the different types of vehicle have the same mean amount of gas emission. So the complement is going to be not all of them, right? Which means it's going to be D. At least one of them going to have different gas emission from others. Okay, fantastic. Moving to next fantastic answer. Determining test statistics. So what we're gonna do here? Here we have our data table, 3 types of green vehicles, 3 types of vehicles, okay, A, B, and C. So we need to get test statistics, right? Opening StatCrunch. It's taking a long time. Okay, we go to one step and at the Way Anova variance. Wait, here it is, Anova, and we choose one way. Okay, so column is gonna be, did I choose one way? Let me go one more time. One way. Okay, we are choosing A, B, and C. Okay, 3 items, and we go to compute. There we go. We have our F stat is 50 point, here it is in Anova table, 50.00 or 001, we shall see. So it's gonna be 50.00, 2 decimals. Okay, we put 2 decimals. Okay, nice work. So that was our test statistics, and this is when I was explaining in the video that mean sum of between and mean sum of within. So between divided by within and give you F test statistics, and that we have 50. Now let's check also p-value, how much it is. Where is p-value? Listen, so it's 0.000, right? We type here 0.00. Okay, nice work. And what conclusion we can draw? Our p-value 0.00 and our alpha 0.025. Our p-value is less than alpha. P-value is less than alpha. We reject null hypothesis, correct? And null hypothesis is our claim, I believe. Yes? Yes. So what do? What conclusion we make? We reject null hypothesis and we conclude that if we reject null hypothesis, then we fail to reject alternative. So that the type of vehicle does appear to affect the amount of greenhouse gas emission for free types. Moving to question number 5. Refer to accompanying data table which shows that the amount of nicotine milligram per cigarette in king size cigarette, 100 milligram menthol cigarette, and 100 millimeters non-menthol cigarettes. The king size cigarettes are non-filtered, while the 100 millimeter menthol cigarettes and 100 millimeter non-menthol cigarettes are filtered. Uses 0.05, meaning 5% significance level, to test the claim that the free cigarettes categories of cigarettes yield the same mean amount of nicotine. Here we go. Null hypothesis, same. Okay, it's gonna be, what do we have here? Same. Okay, which means alternative, it's gonna be at least one is differing. Okay, next question. Find the F statistics. Okay, so let's open and start crunch. All right, where is our Anova? One way. We select all three. Compute. There we go. F statistics 5.1303. 5.1303. It's from Anova table. Okay. .1303. Okay. Four decimals. Okay. All right, we are good. So next we need to find p-value. Going back again, p-value is 0.0129. 0.0129. 0.0129. Okay, we did good job. So now let's see what is going to be the conclusion for this hypothesis test. What was our claim? Our claim was null hypothesis, right? That was all the means were equal. So therefore, we see if we are going to using p-value, we can use two choices. Since we have F test statistics, then we can, through significance level of alpha, let me show you. So we have, let me see, we have alpha 5% and we have p-value, right? Whatever, and we have F test statistics. So we have two choices. I can figure out F critical through the alpha and table, find F critical based on degree of freedom, but I'm not sure if it's not given. Sample size, yeah, it's not given, so we just stick to our p-value, and it's going to be the same way. If p-value is greater than alpha, then we fail to reject null hypothesis. If p-value less than alpha, we reject null hypothesis, and our claim is null hypothesis, by the way. So let's see, what do we have here? p-value 0.01 and blah blah blah, and our alternative 0.01. So our p-value is less than, correct? Therefore, we reject our null hypothesis. Okay, and we reject null hypothesis. It's going to be either B or C. So which one we're going to choose based on whichever will support rejection. This one support, B support rejection. There is sufficient evidence to warrant rejection. Okay. Checking. All right, we are good. More question. So what is going to be, do the filters appear to make difference? Since we reject it and we said rejection meaning they are not equal, that's mean. We can say that given that king size cigarettes have the largest mean, it appears that the filters do make difference, although this conclusion is not justified by the result from analysis of variance. Why did we choose this one? Because we're rejecting null hypothesis. That means we reject the fact that means are equal, which and therefore we choose the answer that say is different. Okay. Question number 6. So which is not property of F distribution? So let's see, what do we have? F distribution is not symmetric. I'm starting backwards. Yes, that is true. Is not symmetric. C, value in F distribution cannot be negative. That is very true, because we know that if this is our F distribution, it's solely in positive quarter, so cannot be negative. And why is it solely in positive quarter? Because F statistics, or whoever watched the video, they know that MS or it's the same thing. So I'm going to write down the formula that is better seen. SS between based on sum of squared within, and because those are squared, so it's gonna be only positive reaction, right? Okay, so its value in the F distribution cannot be negative. That is true. The exact shape of F distribution depends on the two different degrees of freedom. That's very true. If you watch the video, then a lecture, you know that to find critical value, you're gonna use 2 degree of freedom as well as using test statistics also. Okay, so the only thing is not the property is F distribution is bell-shaped. Otherwise, it would call normal distribution, right, instead of F distribution. Okay, moving to question number. Credit for this attempt until you have checked. Oh. Well, okay, next question. So what do we have here? The method, we need to fill in blank. The method of, what method it is we have? Is used for test of hypothesis that free or more population means are equal. That's one way ANOVA and one way analysis of variances. It's one way ANOVA. Okay. Moving to next question, number 8. Also, we need to fill in blank. Let's open so we see what choices is offered. Is a characteristics used in ANOVA but that allowed us to distinguish different population from one another. Okay, is a characteristic used in ANOVA that allows us to distinguish different populations from, okay, it's a treatment. That's a characteristics that used in ANOVA to distinguish different populations from one another. Okay. Next question number 9. Which of the following is not a requirement for using one-way ANOVA, one-way analysis of variance for testing equality of 3 or more population means? What is not requirement? So let's see, starting backwards. The samples are simple random samples of quantitative data. This is a requirement. The different samples are from population that are categorized in only one way. This is also a requirement, which means they are testing only same factor or same independent variable. The population have distribution that are approximately normal, so it's either approximately or indeed normal. And the last one, the samples are matched or paired in some way. This is the one that is not a requirement. They don't have to be matched and they don't have to be paired. Okay. Question number 10. So, which of the following is not true when using one-way analysis of variance for testing equal or free, excuse me, of or more population means? Okay, so let's go step by step. So A, the conclusion that there is sufficient evidence to reject the claim of equal population means does not indicate a particular mean that is different from the others. That is true. Next, the small f-test statistics indicate that decision is to reject the null hypothesis of equal means. That is also true. Actually, no. I thought it's a p-value. No, that one is not true. The small f-test statistics cannot indicate the decision to reject the null hypothesis of equal means. But I'm choosing this one, definitely. But let's see the rest. The numerator of the f-test statistics measures variation between sample means. That is true. And the small p-value indicates the decision is to reject the null hypothesis of equal mean. True. The only case that is not true, it's small f statistics. Test statistic, not. F-test statistic does not indicate anything until you compare F-test statistics to critical value. And how to do that, watch the video and you will find out. Next question. So what do we have here? Which of the following is not true of the test statistics? All right, so about F-test statistics, we need to catch the lie, shortly saying. Okay, A, the F-test statistics is negative, never negative. That is very, very true. Next. F-test statistics is a ratio between mean, and we remember if p-value is less than alpha, then we reject null hypothesis. And since our null hypothesis is our claim, we say that there is sufficient, we need to support that rejection. Therefore, we say there is sufficient evidence to warrant rejection of the claim that measurements of self-esteem are not affected by interaction between subject self-esteem and the target self-esteem. Okay, there does appear to be an effect from an interaction between self-esteem of the subject and perception of self-esteem of target. Okay. We have one more question left here. So, state the null and alternative hypothesis in the test for the effect from the row factor. In this test, a researcher should reject null hypothesis. We already know that, right? And because since the null hypothesis is rejected, there does appear to be an effect from an interaction between subject self-esteem and their perception of the target self-esteem. Okay, so if researcher concludes that there is an interaction effect, which it does appear to be an effect from interaction, right? Conclude that there is an interaction effect, then the researcher should stop at that point and not proceed with any further additional test. So if there is an interaction between factors, the researcher should consider the effect of either factor without considering those of others. But if the researcher concludes that there is no interaction, which is not our case, we will consider that there is an interaction, there is no interaction effect, then researcher should move ahead with further hypothesis test for effect from the row factor and the column factor. Okay, since in our case we say the researchers decided that there is effect from interaction between self-esteem of the subject and the perception of the self-esteem of the target, then we are going to say that in this case the test for effect from row factor should not be done. Okay? Fantastic. Moving ahead, what do we have? What is the value of test statistics? Now, since the test for effect from a row factor should not be done, then there is no value of f to get done. Okay, what else we have here? P-value, same here. So we are done in this case. When there is for test for the effect from row factor should not be done. Okay. Next, state the conclusion of the test. In this case, test for the effect for the row factor should not be done. And is there any null hypothesis? Okay. And again, we are done. If we already know that there is an effect, interactive effect, then we stop. We don't do anything else. So any type of question we answer. There is no question. What is the value of test statistics? I thought I answered this, no? Is this going second time? Okay, let me finish it. It's everywhere. I think it's going second time. I already answered all cases. Oh, next question. There we go. Okay, we are moving to question number 14 finally. All right. So the accompanying table lists pulse rates for 5% significance level and apply the method of two-way analysis of variance. What conclusion can we draw? What is the conclusion? First of all, in the case of two-test ANOVA, for our null hypothesis, there is always going to be, there is no interaction between gender test. and there is interaction between gender and age. So next one, let's check this. We have next one. What is the value of test statistics? Let's open StatCrunch. Okay, what do we have here? This, look here, response, row factor, column factor. This is all in the among the data. So we're going to move here where variable is. So I put here response. Otherwise it's not gonna work. Always pay attention. Sometimes it gets messed up. Okay. Oops. This one we are going to delete. This one, row factor. All right. Moving to this one, cleaning, and this one we have column factor, because we need to find interaction between row and column information. Okay, jumping here, cleaning. So let me see if I can delete this row. No, but I'm not sure. Let's try. Let's see, because there is a space. I should be able to. Oh, here it is, row 1, clear. I highlight on. See here, it popped up. Clear. Move up. There we go. It doesn't move down. Okay, let me put this row 2. Move up. There we go. So what you do, you click on the row 2, since row 1 is becoming available. Oh, no, it didn't do anything. Okay, let me go ahead without it. It's still going to this one. Okay, never mind. I can't get rid of it. Oh, there we go. So let me see if it's gonna act anyhow two-way. So responses, this is gonna be row factor, this is gonna be column factor, and we will check if that's affect or not. So interaction is gonna be 3.71. Let me try. If it would be correct, that's mean that the empty row doesn't affect anyhow. We'll see. 3.71 we set. Oh, that's good. So it doesn't affect. Very good. So next is p-value. Let's look at p-value 0.062, because we are looking into interaction. So 0.062. 0.062. Okay, we are done. Okay, so from here we need to draw conclusion. P-value 0.062, our alpha is 0.05. It is greater than p-value. That means we fail to reject null hypothesis. If we fail to reject, that means it says sufficient evidence to warrant rejection. We can't reject. Therefore, we say there is not sufficient evidence. Okay, blah, blah, blah. There is appear to be, there does not or does appear to be an effect of an interaction. Okay, if we accept it, then there does not appear to be an effect. Why? Based on because we fail to reject. We accepted null hypothesis. Okay, fantastic. We have further. So we need to state a null and alternative hypothesis. So we're gonna go with case that the row values are from population with the same mean, right? With the same mean, okay? Because we are trying to check the mean. What else? What is the value of test statistics for this test? All right, let's go back. Since it's based on a row factor, it's going to be 10.79 or 80. 10.80 for the test. It's a row factor because we are looking for interaction, right, between male and women between below 30 and above 30. So it's a factor row. And 10.80, let's try. 10.80. Okay, we are doing good job. What else we have? What is corresponding p-value? Now we need to find our p-value. Let me go there. Since for the p-value for the test, it's going to be 0.002. Okay. 0.002. All right. Now we need to state conclusion for the test. Okay. We did F test, the test and the other one. So now we are doing test statistic conclusion about this test. Okay. So since our p-value is less than alpha, 0.002 and 0.05, then obviously we are going to reject the null hypothesis and pick, that's mean between A and D, pick the one that gives you sufficient evidence to warrant rejection. So for the row values, right, from population with the same mean. Okay, A and D, what's the difference? It's talking about population with same standard deviation. D talking about population rejection of the row values and from the population with same mean. So D is our case. Okay, now we're moving for the column factor. So we explore interaction between row, right, and test. Now we are looking between column and test. So state a null hypothesis in the test for the effect from the column test. So again, null hypothesis, it's always accepted that column the values from population with the same mean. Where is it? Are from population with the same mean. Here it is, B. Okay. And then we are moving to F statistics. We had here, no? Well, we get over again. Oh no, we changed it and now, hold on, we have to go through all this again. Change test statistics. No, here it is, we have, thank God. Okay, so column factor, we are testing column factor, which is going to be F statistics 4.65. 4.65. Good job. And then p-value, let's take p-value. P-value 0.038. So, oh, 3 decimal. Let's see, 0.038. Okay. And now we need to draw conclusion. Our p-value 0.038, there is 0.05, so it's less than. We reject null hypothesis, and we need to support that rejection. So it's either A or B. Let's see which one supports rejection. Sufficient evidence to warrant rejection, the claim that the column values are from the same mean and the other standard deviation. No, we are looking into mean, right? Same mean or not same mean interaction. Okay. Whew. We finished number 14. So we looked at the interaction between column and between row and test, right? Okay, now we are moving to question number 15. What do we have here? The accompanying data shows a sample of pulse rates, beat per minute, that were categorized with two factors: age, bracket, years, and gender. The data were used to illustrate the use of two Ways Anova. Okay? Which one is how is the result affected by following cases? Okay. A, the same content is added to each sample value. B, each sample value is multiplied, and so on. So let's choose the answer. So the data were used to illustrate two Ways Anova. Here is also messed up. Since our p-value is less than alpha, 0.002 and 0.05, then obviously we are going to reject the null hypothesis and pick, that means between A and D, pick the one that gives you sufficient evidence to warrant rejection. So for the row values, right, from population with the same mean. Okay, A and D, what's the difference? It's talking about population with same standard deviation. D talking about population rejection of the row values, and from the population with same mean. So D is our case. Okay, now we're moving for the column factor. So we explore interaction between row, right, and test. Now we are looking between column and test. So state a null hypothesis in the test for the effect from the column test. So again, null hypothesis, it's always accepted that column the values from population with the same mean. Where is it? Are from population with the same mean. Here it is, B. Okay, and then we are moving to F statistics. We had here, no? Well, we get over again. Oh no, we changed it, and now hold on, we have to go through all this again. Change test statistics. No, here it is. We have, thank God. Okay, so column factor, we are testing column factor, which is going to be F statistics 4.65, 4.65. Good job. And then p-value, let's take p-value. P-value 0.038. So, oh, 3 decimal. Let's see, 0.038. Okay. And now we need to draw conclusion. Our p-value 0.038, there is 0.05, so it's less than. We reject null hypothesis, and we need to support that rejection. So it's either A or B. Let's see which one supports rejection. Sufficient evidence to warrant rejection, the claim that the column values are from the same mean and the other standard deviation. No, we are looking into mean, right? Same mean or not same mean interaction. Okay. And moving to question 16, 15 I eliminated, I removed. So therefore we are doing 16. You will have total 15 questions. So what do we have here? There is, let me open so we can read. There is an between factors if the effect of one of the factors changes for different categories of it. Okay, if one factor is changing, we learned that there can be interaction. So it's going to be the interaction. There is an interaction between two factors if the effect of one of the factors changes for different categories of other factor. Okay, I am done.